Hey viewers, welcome back to this new video today. And so we have been looking so far for the SPI communication at the STM32F1, but really we should have a good example, and we are using today the Nokia. I think I'm a bit too old, so I know it very well, but the Nokia N5110 screen, or the known as the part number, the SKU is the PCD8544, so to have this SPI communication. Good, so let's take a look on it. So for today's video we are going to first discover the hardware, take a look to this screen, understanding it, and then we will deep dive on the PCD8544 datasheet. So there is a really good Arduino sample that we are going to use, and that will be really easy to implement and to make the wiring with the STM32F1. After that, we have to start making the setup function. So we will call it the N5110 init function, and that's the function where we will initialize the screen with the STM32F1. And finally, we will have the N5110 print function to print our hello view word. Good. Okay, so the hardware that we are going to use for the session will be the STM32F1, or aka as usual the blue pill, and we are going to use the Nokia N5110 screen. By the way, this is a picture that I made with a program. It's quite nice and very easy to use. Good, so let's first start by discovering the hardware. Okay, so you can see here a picture of two screens that I bought from two different suppliers. There's one which is good on the right and one not good on the left. So both of them are working, that's really good, and they are having almost the same performance. However, as you can see, the description of the pins, which is quite essential, is quite well indicated here, but really getting a little bit messy in this side, and that's sometimes not really helpful if there's not so many description on the internet. So I quite recommend to take a look on the supplier picture before buying it, and just not having this problem of having the wrong wiring, which can lead sometimes to the destruction of the material. Good. So I took also another picture of the pack for both. So both of them, they do have written the numbers, the number of the pin and the description. In the good one, the one that was good also in the previous slide, they do have written also in the back, which is really great, and they put from 1 to 8, so that's really helpful to understand. However, in the not good one, you can see again that there's no description, and it makes you a little bit lost. So we have discovered, we went through a quick discovery of the hardware. Let's take a pin review. So we have seen that the first one, RST, reset pin, quite simple. The next one is CE, or chip select pin. I don't know what stands for CE, but it's the one that will be connected to the chip select of the SPI. The third one, DC, I'm not sure about what is a D, but this is, I'm sure it's the control, and this is the control pin. We will see more later on the datasheet of the PC, the screen, how this is going to work. The next one, data in, and this is the one that will be connected with the master output pin from the STM32F1, the clock, CL key, clock, and VCC, power supply 3.3. so the screen that I shared with you guys is also be able to get supplied by 5 volt, but please try to connect with a 3.3 volt, because a 5 volt can destroy if there is any type of other devices from other supplier, because this screen that I shared with you guys are able to be connected, as you can see, 3 volt to 5 volt. That's good, but there's maybe a risk to have a problem with that. So let's go back again quickly. Okay, the BL, or this is the pin that will can show the light out of the Nokia, so we are going to use this one later. And finally we have the ground pin that will be connected to our ground. That's really good. So we have seen the review, the hardware. We discussed a little bit about some propriety of the device and which one is good and not good, and nothing better now to take a look to the datasheet of the PCD8544. Well, here we are in front of the PCD8544 datasheet. So my advice is to go really through the datasheet. Today we are going really through the most important point, but take a look on it. There's a lot of very useful information, and this is really enjoyable, so you can really play with the screen quite well. First of all, you can see here that we do have a 48 multiplied by 84. So 48 is a number, let's say offline if we speak like a matrix, and 84 is a number of columns. So in total there is 504 bit or memory that you can fulfill and put it to light. Okay, so after that, let me give you a picture about how this is working. So the screen is split on to 6 banks of data, and each one of them is connected to the RAM. When you send the data for the screen itself, because there's the control data and the screen showing data or the RAM data, you send the data byte by byte, and this is coming and accumulated in that way. So if I send here my first byte, it will be coming here, and then my second byte is also coming here. Imagine I'm sending a byte 100000, so which is 1. Then we will have one here. This LED will be on, and all the other LED will be off. If my next byte is 2, then this one will be off, on, and all the rest will be off. We will really see this more with the example application, but it's simple like that, and the data goes from this direction loading to that direction. So it goes from left to right, and after that came back again and goes from left to right, so from up to down. Okay, so this is in general how the screen is working. It's not that complicated. And the next one, let's take a look to the instruction set. Okay, so you remember we have been reviewing the DC pin. So actually it wasn't a data control, it was a display control. And so when my display control pin is high, which is here, it means I'm writing data. So if I want to write data on my screen, I have to put the display control high, and I will send my byte of data and see how the screen will be showing. Okay, and we do have 2 modes, the display control 1 or 0. On the other mode, we do have the function set. This is a very important mode, extremely important one, because you need to activate your screen. So you can see if your display control is low or 0, and you send a byte with a 1 on the bit number 5. After that, so for example, when you look to PD here, so PD, if PD is 0, your chip is active. Is of PD1, your chip is in power down mode, so you are not able to see nothing. And after that, for the V1, so if the V is 1 here, so it's a horizontal addressing, so it goes from left to right and then go down. But if your V is 1, it's a vertical addressing, so it goes from up to down first. Okay, so it's quite very important to have this setup. And also for the H means, are you going to use, so if you put 1 here on the bit number 5 and 1, or let's start 0 on bit number 0. So it means you would like to go on these options, and one of the very important option here is display control, because if the display control here is 0 0 means you display just blank. So it's quite a very important step, and if you put 1 0, it goes to display mode, normal mode, and then you can send your data. Both of them will accept the data, but when this is a 0 0, everything is blank. Okay, so there is other mode you can discover. There is also some setup for the function when h is 1. Here the bias system, and also they set that the voltage that you would like to set up. This is quite a very important one. We are not going too much on them. There's a bit of details. I really advise you to take a look, but just for saving time, we are going to use some example later on. Okay, and just another important point, there is a very important initialization step. So immediately following power on, the content of all internal resistor and RAM are identified. You have to put a response. Okay, and this is what they call the active low, so the reset should go low at that time. Okay, I hope this is clear. So we have been taking a look to how the display goes. There is a very simple instruction set and how to initialize. And what makes this datasheet really great, they even put it an example at the end. Let's go to the end. Yeah, before going to the end, so when we discussed about SPI application and clock definition, here in page 20 there is important information saying that the maximum frequency that you can supply to your screen is 4 megahertz. Please be careful, more than that can destroy your screen, so just be aware of that. So I think the STM32F1 can go easily for the SPI speed that to 4 megahertz. So we'll set up later our clock for the SPI according to this. Good, let's go a little bit later, and you can see here how to make the reset function during the start. So here we have the VDD, and after that, after the EDD, we have to wait a little bit, push the reset, have a low, and then get back to high. So our reset should be always high, only after the starting of the screen. Okay, so and here they put the whole example. It's quite fantastic. So this is after the reset. So we putting the chip select as low, so it means we are selecting the chip. And first thing they do, so they go to the function set, put PD as a 0, V as a 0, and they select H1, so H1 mode, to put the which voltage we would like to set up. We will make some testing and see if it goes well, and then goes back again to the function set, PD0, V0, and this is to put the display mode, and this is the second one, sorry, the display mode as active. And after finishing this one, you can see, so here my display control is 0 0 0, and when it start 1, it means I can start to sending the data. And you can see here I'm sending 1 1 1 1 1, and you can take a look how this is going to show, and it's just fantastic. So we can write letters like this. Okay, so we had a quick look on this datasheet. We have taken a look to how the screen is working. We taken a look quickly to how to read the data set, and most important, how to initialize. We confirmed the maximum clock speed, and we even have an example to how to start writing our code. So, well, we had a good review of the datasheet. We have seen the most important point, but now before start the coding, there's a very important step, is to wiring with the STM32F1. Let's decide together the pins that we are going to use, and we will be ready to make our code. So this is our wiring. I'm sorry, I tried to as much as possible to make it visible, but this is how it goes. So the decision was to put most of the connection for the control and the data was from the port A. Okay, so for the port A, we are going to take for the port A, pin 0 will be connected to the reset pin, and after that for the port A, pin 1 will be connected to the data control, this one, the display control, and the PA, the port A, pin 2 will be connected to the LED or the light for the screen. We will make the test later and we will see it. And after that, as we do have our SPI pins, so there is the port A, pin 4, which is a chip select, is connected with the select pin, and after that the port A, pin 5, which is the clock, will be connected with the pin of the clock here. And finally the port A, pin 7, it will be connected with data in, so it can send the data, because the port A, pin 7 is the master output slave input pin. We are not going to use the pin 6 because there is no data coming from the screen to the microcontroller. And finally, I'm going to use for the VCC supply and ground, I'm going to use the connection or the stable supply that we do have here, the 3.3, and the ground to the screen. Yeah, we just finished the wiring and we confirmed all the pins that we wanted to connect, and now it's quite a good time to start getting dirty and put in the code. Okay, so let's start doing our setup for the screen and make our init function. Well, so here we are in the code. I'm almost starting from the code of the previous tutorial, just adding here the wiring, and as you can see, I'm doing the wiring but not powering on the screen, and this is just for safety because I don't know what I do have inside my microcontroller as a code, and this is just to protect my screen. So first of all, we will need to upload some code to the microcontroller, be sure that this is the right code for the screen, and after that we can power on a safe way. Okay, so here I just put it the pin connections just in case, and what we are going to do is to work on the steps that are already provided by the datasheet, so just to make the example simpler, but we are trying to understand the instruction set that we have seen in the previous part. Okay, let's first set up quickly the reset, the reset pin, the display control, and the screen light pin. So what we go for the reset, we said the reset is the pin 0. So let's quickly go to it. So init JP. So it's a port A, pin 0, and I would like to have an output, a very fast output. And after that, it's an output for a general purpose use as a pull-up. Okay, and quickly after that, as soon as we initialize the reset pin, we need to start the reset function. So first of all, we have to set it high. So we put the write JP right on the general purpose for the port A. Then it's the pin 0 and we would like to be high. Okay, and after that, so we have to wait for 10 milliseconds, and after that, so we just copy again, we have to go low, and so this is our reset. So this is the reset of screen, and after that we go back to high, so ready to use mode. Okay, so quite easy. Then next I will set up the pin for the display control, which is, we will use exactly the same function here, and pin is 1, so quite quickly. And also we will set up this pin as low immediately, as we would like to have some control activity first. So this is pin 1 and not pin 0. Okay, finally for this first step we are going to set up as usual. So this pin, let's initialize it. So this is a pin 2 for the light, and we are going to have a test for 1 second. We are testing the screen light for 1 second, so let's put it high at the beginning. It's high, and then we are going to put it as, just a moment, okay, put it here as we will wait, put a delay function for 1000 millisecond or 1 second. Okay, so now we set up the rest of the pins, because after that I have the SPI init where I will set up my the initial my SPI pins. So let's save and check if there is no error in the program. Okay, no error, no. So what I will have to do now is to remove my screen first from powering my microcontroller, load my code, okay, unpower or plug off my microcontroller, add back again, connect my screen, okay, connection are aligned, and powering back again. Okay, so I do have my screen blinking for 1 second. Let me load my code again. Yeah, fantastic. So the screen is blinking for 1 second, working properly, so I can jump to the next step, which is more connected to the programming of the screen of the Nokia. So we are going to use this 3 or 4 first steps. The step 1, where we have to push the chip select, this one is already incorporated in the function we created in our previous tutorial, which is the SPI TX function. SPI TX function, and we are going to use SPI1 as we initialized SPI1, and we are going to send this number. So this is a binary. I'm going to use hexadecimal just for easier to understand for me, and which will be 2 and 1. Okay, this is the code I'm going to use. It's exactly the same byte, and the display control is set to low. We already made this action here, but let's quickly jump to the instruction set manual to see it. So we are sending 2 0, like here 2 1, sorry, which means here this is 1 and 0 0 0 1. It means the H is 1, and if we read here, means if H is equal 1, extended instruction set. So when we are going, the next instruction we are going to send will go through this one, and we'll check. Okay, and if you can see here, so if I zoom here, so if I do send this a byte, sorry, with a bit 1 at the position, at this position for the bit 8, it means I would like to set up the voltage that will be supplied to my screen. So let's go back again and see what we are going to send. And we are going to send, so this one, which is here 8, and this is a 1, so it's a 90, sorry. Okay, 90. Okay, so let's quickly go back and understand. So this is the voltage that we are going to supply, and if you want to get more details, this is here. So the voltages, so it goes from V1 to V6, which is from VOP operation 6 to 1, and the stronger the number, the stronger your number here, the more voltage you are supplying to your screen. And also this is giving more contrast to your screen, so that's something that we may use later to level and to see if I have a good display from my screen. Okay, let's go back again to my example. Sorry. So if I go here, so the next function I'm sending is to come back to the function set and stop using the extended extraction set. So just copy this one and go to 0 to 0. So it's exactly same as the step number 2, but we are removing this one. So this is what I'm doing. And if I jump to the instruction set, you can see that I put h to 0, and when h is 0 means I'm using the basic instruction set. Okay. And the final step before start writing the data, so I'm going to go display control set to normal mode, and where we put d equal 1 and e equal 0, the instruction means I'm sending a 0 an hexadecimal number of 0c. Okay, so 0c. Okay, so now I set up my whole screen. Let's go back quickly to understand what is the 0c, just to read the instruction set. So first of all, I put 1 0, so I said to my screen that I would like to use the basic instruction set, and after that I sent a 1 here, so the display control, I sent 1 1 0 0, and it means d is equal to 1, e equal to 0, and if I read here for d and e, if I do have 1 0, I am in a normal mode. Great, so everything is set up well, so I'm ready to send up my data and start making. I will send only the first 3 because now the first part, this part of the video, is just to set up the screen, and let's see how the screen is working. So I will go within my while loop, and first of all, to prepare to start sending data, I have to put the display control to high, which is this one. So this is the JP we set up to high here. Okay, and we start sending some data. We are going to send quickly this one. So this is a 1 1 here and 1 1 1 1. It's quite easy one. It's 1F. Okay, and after that is a 1 0 1. So it's a 5. Okay, so 0 5, and the last one is 1 1 1. It's a 0 7. Okay, and after we close this P, we are going to add 2 blank spaces. So I'm putting here as a 0 and another one here as a 0. Okay, I think we should put some delay. So first we put here low, just to close the instruction, and have some delay of half a second to see how the progress is going into my display screen. And finally, let's check it by making a toggling and of the screen blinking. So toggling JP, and it's a PA, the port A. We are using the screen light as a pin 2, and here we are. So this is just an indicator to see if the code is working or not for debugging purposes. Let's save, run, see, 0 error, 0 warning. Okay, fantastic. So let's quickly put the code, load the code. Okay, so we do have a blinking, but nothing is showing here. Fantastic. And so the first thing to check is, so we are inside the loop, and we are not sure if there is a data going through or not. Maybe one of the things to check first is about the voltage that we apply, the VOP, and this is depend on how you are supplying your screen, the power you are using to supply your screen. But just in case as a first test, try to increase a little bit the contrast that you do supplying. So let me make this one smaller, and the contrast is increasing. The more you put the number, the more the number is increasing in this side, so the more you are putting contrast to this screen. So let's increase a little bit, and let's put, for example, C. Put a little bit more. Let's save. Okay, run, no error, and upload the code. Okay, we can see here, so it's just redundant, but we can see that the code is getting written here, and we do have a lot of P's written in the screen, and also you can see that this is kind of writing again and again and again and again. That's really fantastic. So we initialized our screen. It's really a few lines, quite very easy to do. So what we are going to do now, so the purpose of this video is to prepare the initialization function for the screen setup. So let's go and start create the screen. So we call it the N110 drive. Okay, and also the H or the header. So let's call it N5110 drive. Okay, let's put this one here. Okay, so let's just quickly copy all this. We set up all of this one, and we put it in the, okay, I think the screen is not big enough. Yeah, we put this one right here, and we call our init function. So let's call void N5110 init. So for this one we need to set up the SPI. So this is unsigned char or unsigned short actually, and we call it SPI. I think that's all. Okay, we can even, so of course we need to add some libraries here. So let's go back and copy the SPI drive and also the GP drive, even also this one too, and we go here. We should be good, and let's include also the N5110 drive header .h. I'll be adding this one here too. Okay, and let's quickly, so for the SPI we add this SPI to the SPI that we would like to init. This is just in case if you guys would like to use the other one, and we do have the function ready. So just we copy here and we add this one. Okay, so we can remove all this code. So after exactly the sysdig in it, we just put a 1 here. Okay, so the code is ready. Let's save. I guess I need to add an extra line to not get the warning. Yep, so let's save. Okay, I do have 2 warnings anyway, so what will say, okay, in which file? Yeah, for drive.h. Yeah, I forgot to add this one. Let's save for all, run my code, 0 error, 0 warning. So let's remove this just to show how the code can be clean now, and save, compile, and let's make the code a little bit smaller, the screen, sorry, a little bit smaller, and load the code. Yeah, we do have our screen writing. That's perfect. We have finally finished the setup function, and we are going now to the final step of setting up the print function. So now this is our final step, where we are going to be able to print the text that we want on the Nokia screen. This is finally the last step, and you can see now we do have a gibberish, something that is piling the p each time, and that's quite a nonsense. So let's start first by removing this code here, and the function that we would like to get here is something like this: n5110 print, where we will decide the position, the x position and y position. Let's put first 0 0, and after that we will put hello WeeW. Okay, easy. So this should print hello WeeW here in this screen and at the position 0 0. Okay, so let's go to the library and start creating this function. So we will first start by writing the string in the screen. After that, we will check how we can set up the position of the string, and finally how to clean the string and not to have this piling letters that are not erased. Okay, so void. And first we will have a short as a y position, then another short as a x position, and finally we will have a char as a string, and it will be an str. Okay, so let's start first by the first thing is to write the string. Sorry. So as you can see, we have seen also in the tutorial that provided, so the letter is written by turning on and off certain LEDs, and that's how you will turn this, you will get this character. And actually there is someone who already helped to create all the characters. So if you go to this Arduino page called Philips PCD8544, someone has already went through all the details and put the letter. So you can see here, this is the number, the char number, but you can see here all the how to write all these characters. So let's, for example, go for the P again. If we go for this small p, so he putting first 7c and then 1 4 1 4 1 4 and then 8. So he's putting like this is the 7c, the first line, and then 1 4 1 4 1 4 and then 0 8 to close it. So this is how the logic we are going to use. So we are getting this array here, okay, and we are going to paste it here. Okay, so we do have an error. Oh yeah, because the guys is using C++ and Arduino code. We are not using that, so we are going to use here we will be using a char. Okay, good. So how to go through the string? What we have to do, we need to get in kind of iterative point. So we put int I and also another one j, we will understand later. So first we initialize I equal to 0, and we are going first to loop while str of I, so while we still have a character, so we don't need to check anything else. So what are we going to do? So first always increment the I, just to not forget it, and we are going to loop each time for, go here, j equal to 0, j is less than 5, and put j++. You will understand in a very short moment what I'm going to do. So I will be looping in the string in the ASCII array. So I will be writing SPI TX or transmit for each time, and I'll be writing so I will be sending this array, but the position here will be str of I, and this one will be J. Okay, let me explain again what's happening. So we are inserting the chars in the string, so we are looking for which char will be in the string. For example, I'm sending here hello WeeW. So first I will take H as a hello, and H is already having, if you translate it to the ASCII code, it will give you a number, and this number is exactly the same one that we do have here in this array. So H is equal to 48, so it will take you to this position, and after that I will be looping through this position H. When we reach this line this row 8, we will be looping through this columns, and we will be printing them in the screen. Okay, so let's close this and check. I think I've been missing something. TX, so do we have this one? Something is missing. So strj, so this one is closed. So why do we have an issue here? Let's read. Too few arguments, of course, because I have to select. I'll be sending through the SPI1. Okay, so far good. So before doing that, I need also to put the display control as high. So let's go to display control, which is this one. No, not this one. This is the display control, and let's write here as high. Okay, and another one here. We go back to low after sending. So actually we don't need to do it within this loop. We can do it even higher here to avoid any extra processing time. Okay, X. So after finishing this loop, we can go to low. Okay, looks good. And just to avoid that text will be, because we are going to loop on this one. Okay, there's something missing. Yeah, of course, I need to add this function to the header file here. Okay, let's check. Perfect. So let's take a look now and what would appear in the screen if. Okay, one warning, this is probably coming from me as usual forgetting the last 9. Save. Let me close this. Yeah, 0 and jump. Let's what we see. Okay, something very strange happening. Okay, this is not really what we need, and it's quite very obvious because when I added the string here, the ASCII number for the char, I have to put -32. Let's save. I always do this mistake. Okay, let's check. Yeah, we do. Hello WeeW, hello WeeW, hello WeeW. That's fantastic. That's really fantastic. So we already can write whatever we want, but here we are writing a bit too much. Let's go to the next step, and before writing the WeeW, so I will changing instead of the position, I will put cleaning the whole screen first. Okay, so cleaning the screen is a very simple and easy task. So as usual, we have to go here, put my display control high and low, and what I'll be doing, so So I'll be using this loop, and instead of writing all these ones, so for j, yeah, I need to put this one up. Sorry, it's getting a little bit messy. Okay, so initializing again, and I'll be putting for all this, I'll be writing just a 0x00. Okay, but I'll be not writing for this one. It would be for j less than 504. Okay, let's check what would happen then. Okay, so you can see that each time it's moving, because this one is pushing a little bit, each time pushing a little bit, and now by cleaning and organizing the position, we will have a much better picture. So to work on the position, there is two ways. You can work on it on a hard line, like determine when will be your position, or there is a very simple and very good function that is shared in the function set. Let's go to the function set here. So if we put h equals 0 and use the basic function set, we can set the y address that we would like to start with, and set also the x address that we would like to start with. So to do so, it's quite simple. So we will have to disable our display control, go to the h, set up as function set a normal one, and then go set up this y address and x address. Okay, let's put it as we call it N511 pos function, something quite easy. So void, and it will be short y pos x pos. So we can use this one each time we want. Okay, so this is also a short. Good. So what we are going to use here, so first we need to go basic function. Yeah, and usually before even setting up all this, better to put the control one low, just in case. Always put it low, so the display control is low. We are sure that we are sending the right information. And after setting up that we would like to have the basic control, what we are going to do is to put, so what we need to send for the y address, it's 1 here, so 1 in the bit number 6, so it's 4. And after that, the position I just need to put my y position here, and after that I don't even need, I see, yeah, let's make y position, and we will have or, so here we will have the 0 1 here, so 4 0, and it will be with a y position. Okay, good. So, and for this one, same thing, but for the x we will have 8 0 or, and it will be x position, the x position, and we will put like this. Okay, let's put like this here, and this one too, just to avoid any risk of computation. So should be good. Okay, so let's use this function directly. We go here, and for cleaning the screen we put first 0 0, so we start cleaning from 0 0. And yeah, I need to, okay, there's an error in this position, conflicting type. Okay, Probably I need to set it in the header file. Okay, yeah, so now it's working. And for my position for the text here, before I start writing, I just put my position, which will be the Y position and X position. Okay, that will be here, and X position. Okay, so far looks good. So let's run again. So let's check if we do have anything. No. Let's put and check the video. Okay, hello world in 00. Perfect. So let's change a little bit. So if we would like in row number 5, and let's say 10 to see what will happen. Okay, so column 5 is a little bit too much. Let's put 3 in the middle. And wonderful. So we could have our text written as we want at the position X and Y position that we need. I think that's a great job. Thank you a lot. WeeW!